Welcome back. Today we're going to be doing an optimization example using the open top box. A box with square bases and an open top must have the volume of 32,000 square centimeters. What dimensions minimize its surface area? Okay, cool. So first I want to talk about how do we find the surface area of an open top box. Now this box has a square base. So if I draw this box, I'm just going to draw a regular cube and we're going to picture that the top is not on it. So therefore there will be one less surface than normally that we would have, because normally there would be six surfaces on like a box or rectangular prism or cube, something like that. In this case, there will just be five. So we'll keep that in mind as we're doing this. Okay. Okay, so there we go. Excellent. Open top box. So in this case here, it says it's a square base. So I'm going to label the base as, let's do x times x. And then let's have the height be y because we don't necessarily know if the height is going to be the same or different. Now, because it's an open top box, the surface area is going to be x squared. So this bottom surface, x times x or x squared. And then we have four faces around, x times y over here, x times y over here, x times y over here, and x times y over here, like that. So that's going to be plus 4xy. And so that's our equation for the surface area, and that's what we would like to minimize ideally in order to essentially save money on whatever packaging we're making for this while still having the volume that we want. Okay, so next I'm going to use the volume equation here in order to be able to simplify the surface area equation a bit further, because at this point we don't really know enough information. Okay, so in general, we know that volume is equal to length times width times height. In this case, it's just going to be x times y. So therefore, in this case, we can say that 32,000 square centimeters, which is our volume, is going to be x squared times y. Now, the thing is, what we really want to do is we want to be able to eliminate this y by subbing in some equation with respect to x for it. So that way we can have the surface area just in terms of x and not in terms of y as well. So I'm going to do that by dividing both sides by x squared of this equation. So I'm going to get that y is equal to 32,000 over x squared. Therefore, the surface area is equal to x squared plus 4 times x times y, which is 32,000 over x squared. And that is going to be x squared plus, well, let's see, what is 4 times 32,000? 4 times 32,000 is going to be 128,000. So that's going to be 128,000. And then we have an x squared in the denominator and an x in the numerator. So that's going to simplify to x the power of -1. And the reason I'm writing this way is because we are about to differentiate. Okay, so for my next step, I'm going to differentiate this because a reminder that in order to optimize anything in general, we always need to take the derivative and then set that derivative to 0 and solve. So that's what I'm going to do here. I'm going to take the first derivative, which is going to give me 2x minus 128,000 times x to the power -2, or we could even just say over x squared. So that's my step of taking the derivative, just using power rule. Then in my next step, I'm actually going to set that derivative to 0 to get that 0 is equal to 2x minus 128,000 over x squared. Then if I add the 128,000 over x squared to both sides, I'm going to get 128,000 over x squared is equal to 2x. Then if I multiply both sides by 2x and divide both sides by x squared, multiply both sides by x squared, and then divide both sides by 2, I get that x cubed is equal to 128,000 divided by 2. And let's figure out what that is. 64,000. So x cubed is equal to 64,000, which is nice and convenient because the cube root of 64,000 is 40. Okay, cool. So we got part of our answer. X is 40, and that's great. Now let's go back to what was the original question. It asked the dimensions that minimize the surface area. So we know one of those already. We know that one of those is x, but we also need to know what y is. Now, luckily for us, earlier we made an equation expressing that. We said that y is equal to 32,000 divided by x squared. So that's going to be divided by 40 squared. And then if we type that in our calculator, we get 32,000 divided by 1600, which is 20. And so therefore we get that the dimensions are 40 by 40 by 20. And those are all centimeters like that. And the reason I put 40 in there twice is because keep in mind x is the dimension there twice. We have x by y because it's an open top box with a square base specifically. All right. Well, as always, if you guys do have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.